Welcome to today's webinar. Oh, thanks, April. Good day, everyone, and welcome to today's webinar hosted by the California Leafy Greens Marketing Agreement. I'm Greg Komar, the Technical Director of the California LGMA, and we are very glad you could join us for today's Lunch and Learn. Helping with any Q&A for today's webinar is April Ward, who oversees the LGMA communications. If you have a question, please put them in the chat, and April will help lead the Q&A after the webinar presentation if there's time permitting. So we are expecting to have about a 30-minute webinar here today. We can go a little bit more if that's necessary, but that is the time we're trying to keep to for today's webinar. For questions we aren't able to get to, we'll try to answer them after the webinar and post the responses on the website. This webinar is being recorded and will be available to all of today's participants and will be on the LGMA's website for future access. You can go to lgma.ca.gov where you will find the recording at our technical resource library. With the recent changes to the LGMA's harvest equipment cleaning and sanitation metrics, we are dedicating today's session to harvest equipment sanitary design reviews. As you all know, harvest equipment cleaning and sanitizing plays a critical role in protecting the integrity of our products. Having harvest equipment that can be effectively cleaned and sanitized is essential for reducing risk and ensuring the safety of leafy greens and other fresh products. We're fortunate to be joined by 3 experts from Factor 4 Solutions, a company dedicated to helping the produce industry strengthen their cleaning and sanitation programs and training. Our panel today includes Justin Kerr, founder and owner of Factor 4 Solutions. Justin founded Factor 4 in 2013 and has decades of boots on the ground experience in sanitation. He's a trusted advisor to many produce companies across the industry and consistently helps the leafy greens industry with resource development and the review of sanitation best practices. He was a key contributing member of the Harvest Equipment Cleaning and Sanitation Working Group that provided the draft language for the recent LGMA metrics update for harvest equipment cleaning and sanitation. Mark Torres and Giovanni Espinoza are also members of the Factor 4 Solutions team and also bring extensive hands-on knowledge in equipment sanitation, with a strong background in implementing solutions in the field and facility environments. Together, Justin, Mark, and Giovanni will provide their insights into sanitary design reviews, review common challenges they see in the field, and share practical ideas to help with the cleaning and sanitizing of harvest equipment that have different levels of cleaning challenges. With that, let's dive right in. Turning it over to Justin. Thanks, Justin.
Hey, good afternoon. Appreciate the opportunity to participate in this and continue to share our approach, lessons learned in the field. We've got a quick set of slides, really just a lot of pictures and meant for discussion. So by all means, feel free to put a question or a thought into the chat and we'll try to address those as we go. And with that, I'm going to go ahead and click through. Opening slide here, kind of dealing with the legacy equipment in the field. Hygienic design can be a daunting task. I know we've got some timelines starting September 1st with completion of our Category 1 hygienic design inspections. So as we go out to the field, it's trying to collect information, trying to gather data and build our programs. So kind of a fun slide here, the benefits of AI and messing around. Let's see. So the purpose of the hygienic design inspections, of course, we've got audit and customer expectations. Hygienic review serves as a part of a risk assessment for each machine. So as we start to go out and identify, how well our equipment is assembled and designed, we're essentially doing some sort of a risk assessment, managing where harborage points are, where design is maybe creating a challenge that we can correct. We're also doing these to establish periodic equipment conditioning, which we'll refer to as PECs or master sanitation tasks. So within your master sanitation schedule, as you look at equipment, you may have similar machines that require the same frequencies, and you may have the one-off machine that requires more attention. So it's a good opportunity to establish timelines and frequencies for deeper dive, belt removal, equipment disassembly, etc. Also serves as a way to understand the routine requirements for chemicals, tools, and staffing to maintain the equipment. So not only are we looking at the design, but we're looking at what the challenges of the design may require with those resources. And then also to create the preventative maintenance schedules. So with field maintenance trucks and access to yards and whatnot, the hygienic design serves a good purpose to look at, where do we have conduit running? Where do we have hydraulics, drip pans, other serviceable needs on the equipment to make sure it stays operating for both sound production and sanitation. And then last but not least is that this hygienic design helps us improve future capital investments. So the next machine that's being built for harvest in the future or modifications are being made, you can use these hygienic design inspections to improve and dollarize what needs to be invested in. Through the Section 8 update and the Appendix S that's out for everyone to look at from Western Growers, we established 3 categories of equipment. And the category 1 equipment, which I'll read through real quick, is really where we're stressing to do the hygienic design because of the nature of the products harvested and the methods in which they're harvested. So equipment used to harvest lettuce or leafy greens for further processing, i.e. clean and core, top and tail romaine, mechanical harvesting of leafy greens. Examples of food contact surfaces include belts with cleats, mechanical blades, coring rings, knives, and cutting boards. We're not going to go through the entire hygienic design questionnaire, but we're going to hit some topics that we can show examples of things you might run across. The important thing is the scoring is kind of self-scoring, right? So the way you score things, you want to be able to justify and understand. So if there's no issue, you would score it as a 0. And then you've got 1, 3, and 5. You may choose to use a 2 and a 4 if you want to encourage or give yourself room to establish, hey, this is somewhere between medium and low risk. Maybe some changes have been made when it was scored a 3 and you're working towards getting to a 1 or a 0. So your scoring, your method is really up to you and your team on how you choose to do that. The important thing is to look at the machines and digest all the questions and see where that machine falls as far as your scoring. The design of the harvester sanitation program is another reason we're doing this. So I mentioned it a little bit, but understanding the hygienic design of the equipment helps build the sanitation program. Which machines need the greater attention based on design challenges? Which machines should you possibly increase verifications? I know in the appendix, we refer to seasonal verifications of SSOPs. But if you're out and you see design challenges and things that are difficult to clean and sanitize, then you may choose to get some more data pertaining to the ability to routinely clean that machine effectively. What machines need more frequent disassembly is another item. So there may be some things, belt tensioning on one harvester and not on another. So you may need to remove belts to get better access. And then what machines need immediate attention. So obviously, if you're out there and you see any blatant items, you're wanting to score it as a 3 or a 4 or possibly a 5, you can elevate and get the appropriate resources to solve. In the Western Growers Appendix S, there's a definition of food contact surfaces and non-food contact surfaces. So the first couple of slides are going to be around accessibility to food contact surfaces. The one thing we should all be aware of, and it's not specifically stated here, but food contact is also related to items that may drip, drain, or draw onto those surfaces. So catch pans, motor pans, overhead structure, you want to pay attention to those items and how they may affect those zone 1 food contact surfaces. So accessibility to food contact surfaces, these are 2 examples of old, but are the employees first thing first, right? If you go out there before you start looking at nuts and bolts and welds and disassembly, do we have good, adequate access to the equipment? Are they using the ladder and working from below, or are they able to lower it and actually get to surfaces? So I'll just hit play here for a second so you can see it in action. So two different approaches. If you're working on a ladder and you're working from below versus being able to lower that incline down, it's going to be a hygienic design factor. You start to look at the hydraulics and the cable strength and durability of how low you can get that incline, but obviously getting things down closer to the ground for employees to get leverage and cleaning is important. The other thing is going to be surface and materials. So again, it's just a lunch and learn, some quick stuff. So of late, we've seen a lot of trial equipment that's been brought out to the fields, ways to do things quicker, faster, go through. So if it's a category one type machine and you see, foam rollers and porous belting, and it's for design trial, you still need to do a hygienic review on it, and you need to make notes because most likely ownership and the powers that be are discussing how to advance that. So it's important that we look at all equipment, not just the legacy equipment running, but understand the trial equipment and what's going on. We've got a lot of vinyl backed cloth belts, and you'll see that they start aging, and you've got a lot of challenges in cleaning. So food contact on a belt is going to be both the top of the belt and the underside of the belt, because as that belt's running, you've got a chlorine spray tunnel, you've got moisture, you got water, it's returning under the product feed. So you've got a lot of that drip, drain, draw, and zone one food contact concern. So during a PEC or during a master sanitation event, those are great times to include your design review to see what the durability and what the lifespan remaining in belts are. So here's an example, trying to clean and get those belts back to a tangible, usable belt. And at some point, you've got to make a decision. Hey, is this in our scoring module? Hey, is this a 1? Is this a 5? Should I just not allow this belt to go back out to the field and get it replaced? And I know a lot of times that requires, forward thinking on ordering and seeing if belts are available at the right sizes, lengths, widths, components. So just an overall review is to go do hygienic design out in the field while it's all assembled is not always the best. So you go out and when they're doing a PEC, and you can get into the nooks and crannies and see things that may be hidden on a regular basis. When you're out in the field, some things, again, this is what to expect when you're inspecting. So we're talking about access, we're talking about trial equipment. Here we're looking at welds and wearing of equipment. So on the left side here, we've got a cracked weld directly adjacent to food contact surface. This is one that you may not halt production and say, hey, we're not running until this is fixed, but this is one where you might make the decision to score this on a lower scale. Maybe it's a 3 or a 4, and you're sending out emails and asking for repair and maintenance of those welds. This picture on the right side is showing with the belt removed, again, during a PEC disassembly. You've got worn down UHMW. You've got a really poor kind of tack welded surface right next to the food contact. And then you've got some tough access points here when the belt is in place. So this is another one scoring wise where you might say, hey, we're producing good product on this. Can we continue to do so with the current state? It's likely if you have good sanitation and they're able to get belt tension and get inside of there. But do we want to risk foreign material from a degrading UHMW piece? And is that weld over there really giving us benefit to sleep well at night? So this might be a middle of the road scoring to say, hey, we need to get that weld repaired and we need to get that UHMW repaired as soon as possible. Again, these are just guidance and kind of what to expect, and then you and your team can make decisions on what you think is the best fit. So in the Western Growers Appendix S, it's a good read prior to doing your hygienic review. So you go out and look at basic concepts of harborage sites. It's spelled out. Ledges, conveyor belts, equipment seams, temporary repairs, unsanitary welds, enclosed hollow part structures accessible to water and dust. So got a few examples here where at first glance you say, hey, I like this. It's a lot of good access to cleaning this bar belt. But then you realize that the white pieces are actually running on a ledge. So that underside of the ledge is a good spot to look at and see if you've got any kind of buildup because the angles and the visibility of the employees cleaning. So you're looking at design, you've got a likely harborage spot on that flat 90-degree angle underneath. You review it, you talk to your sanitation employees, and you might score this to say, hey, it's a 0 or a 1 because we can get it clean. But the next time a system's being built, harvest equipment, you say, okay, is there a better way for us to do that? Probably not, but it's worth looking at and understanding. Here, this is more of a category 2 where you're boxing product, but I thought I'd point out, the back of this pan, it's a little bit hard to see, has some welded pieces and kind of a catch point at the back of the pan. So as they're filling boxes and doing things, we got to look at this as a zone 1/2, depending on if they're cutting on there and then loading the box. What's the risk of water and product accumulating? And then the biggest thing we see is some of these tables don't get folded up to wash the bottom of them. So now you've got a lip and an edge that employees are in contact with repeatedly throughout their harvesting shift, and you've got possibility for buildup. So you can dive into the smallest and most difficult things, and then you can look at some of the more obvious things and say, hey, is that the best design for a table? Does it drain well? Does it catch? Is it able to be moved for sanitation in an easy fashion so the employees can clean the bottom? Other harborage points. So on some of the equipment, we've got just known hauling braces where when they're loaded on the trucks, they have to be tied down and they've got various pieces. So they become a hollow niche, a hard area to get in and scrub, but knowing where those are on a machine and knowing that you've got to get ample detergent, pressure wash, and sanitize in those areas will allow for peace of mind that you've got a difficult design, but it's manageable with routine, knowledgeable sanitation. Here, this is with the belt off. This was a little bit hard to see when the conveyor was running, but it was still visible. But here you've got about a 1/2-inch gap where there was a guide welded over another guide. And so you've got a space behind that's likely to fill with product and water during sanitation. In your hygienic design review, you might score this as a 3 or a 4. You may not make the decision that, hey, we've got to stop production until this is fixed, but you need to get with your maintenance team, come up with some ideas to understand why that guard's there and if the spacing can be possibly increased or if it can just be welded and sealed so that there's no space for product and water to accumulate. So this on conveyors, we start to look at access and going here. You might be out doing a routine sanitation review, doing some hygienic review on a machine. We've got good access to get inside of this conveyor, but then the SSOP is falling apart on us because they've got detergent on the belt, but they still got tons of product stuck in there. So yeah, we're talking hygienic design, but good hygienic design still needs support of good, solid, verified SSOPs and training. And then here we've got a tough access point. We've got a difficult, this is a lot of the drives on these rollers need to have some sort of bite to them to help keep the conveyor in line and cleanable. Same time, this is one where you might score it in that 3 or 4 range and say, okay, how do we prevent this from being in our design in the future? Is it the type of belting? Is it the design, the slope? What can be done to prevent having padded rollers to drive belts? So you can see the crisscross pattern on that, and imagine that you've got leaves and product in there that with outside access, it's very difficult to rinse, get detergent, and sanitize. So here's just an example of belt tensioning device. So you can see the lever over on the right is lifted up, releases the tension, and now you have access for the sanitation employees to lift the belt, go through, remove all the product, apply detergent, scrub, and do that without, without access holes on the sides. This is the best way and most recommended way to go. So as you have a design review, you can look at it and say, do we have belt tensioning devices? If we don't, what's the cost or availability in the design to incorporate those? So repeatability and like equipment comparisons. So sometimes you get to see equipment right next to each other. Other times, you're miles and miles in between. The picture on the right, the other one's a video I'll hit play on in a second, but the picture on the right, 2 very similar machines. One thing you might call out is to say, okay, this one has a different belting used as a guide for filling the bins. This one looks like it's a vinyl cloth. If this one's not a vinyl cloth and it's more of a monolithic or some sort of material that's non-absorbent, you've got 2 machines next to each other. You take a look at them and say, hey, maybe I want to use that piece over here as well because it's easier to clean. And then here, another example of SSOPs, but with design, you've got a long belt and you've got where's the best spot to rinse? Do we have good access? And so you can see sitting at the end of this conveyor when I hit play on the video, you've got action and the ability to apply detergent and get physical action with the pressure washer and sanitize. But this involves the employee being camped out at one end. A lot of times we see employees running back and forth, doing good work, looking busy, but the best spot is sometimes to sit still and let the conveyor come to you. So So access and ability to get in. This is another little video, but this is a very difficult design. We've got a lot of little sandwich joints in here. We've got some slide fit pieces, so water, product, moisture can build up in there. And then as you'll see, we've got product coming out with the detergent. And how long can you assure that this is staying clean inside without having access? So this would be one where you might mark it as a 3 and say, hey, we're getting detergency, we're getting some physical action in there, but we need to get some access holes cut in this side panel so we can get physical action from the pressure washer and prevent this from being the scenario. So we're kind of going through here fast. If there's any questions, I don't know, April, are we good on questions or anything right now, or I can address them as we get to the end?
I don't see any questions right now, but for anybody who joined late, you can feel free to type them into the chat box and we'll share them with Justin and his team to get answers for you.
Okay, so moving along, when you're doing your hygienic review, one of the important things is, the routine access, but then also looking at your periodic equipment conditioning, the PECs or the master sanitation schedule. And so when you look at a lot of the designs, we start to see sandwich joints of UHMW on top of stainless, and often there's a hex head bolt about every 4 feet on the UHMW. And so you end up with a very difficult disassembly, and you've got a sandwich joint that you do need to address in cleaning between the UHMW and the stainless. And then the PECs offer a great opportunity to do those seasonal verifications. So when you have all the belting off, you can inspect the equipment. You're looking at hygienic design. You can do a thorough cleaning. You might have a mixed acid alkaline type wash where you're doing a 2-step. You might be mixing in Sterilex or some other products that are available on the market for the deep clean, but these would be good times to get verifications done. And you can see, with access, you're getting foam into areas that may be difficult and when the belting's all in place. So here's furthering disassembly and why, hygienic design review during disassembly is important. Picture on the left, you can see the conveyor runs across these guides, wraps around. You would not be able to see this niche, this harborage point. So you got a spot welded end on this, and then you've also got these hollow surfaces. And you can see there's quite a bit of debris in the trough there when we remove the belt. So this is a pretty common design on 3-point harvesters and some of the bin loaders. So one to look out for and watch. And then the other part is in disassembly, you can see here there's some numbers that were written, but it's a big task. So maintenance and sanitation work together to remove all these guides to get these cleaned on their seasonal wash. But you've got a design issue in that you've got, hundreds of hex head bolts and then different links and cuts. So these are things you can take a look at. Again, they're not going to be a stop harvest, can't get it done, but these are things during your hygienic design that might help design the next future harvester to have less of this, less time and effort in your breakdown and cleaning. We've got a lot of hydraulics and drip pan challenges. Here I've circled one in one of our reviews in the field. Hey, we've got a drip pan, but we don't have any way for that to drain. And as you guys know, these collars on the tops of the inclines are moving. They're going over bins, they're pulling back, they're raising, lowering, tilting, and you end up with challenges that, okay, if I put a drain there, where do I drain to? And if I don't have a drain there, where is any sanitation water dumping or going? So on a hygienic design review, you might score this and say, hey, we've got to get some sort of drain. Can we run braided hose down the side of the incline? Is that always going to be drainable? And then on the flip side of that, there's drains that are out there, but they don't get maintained well. And then you start to see plugged and product and debris that are backing those up. So it takes a team effort. You got to work with maintenance and come up with ideas to prevent the hydraulic risk from getting into product, but also prevent having a tray that fills up with product and water and spills into bins on a regular basis. These are a little bit along hygienic design and the PEC piece, but how are we going to clean and sanitize? So you can work on SSOPs of what to do with the belts. Here they were dipping it in a water solution to do detergent, let them soak, and then roll them out as we saw earlier for scrubbing. And then you get into some real simple things. So knives are called out in your design, but then we have storage. So a lot of these knife boxes have a piano hinge on the back of them. They're sandwiched right up against stainless steel surfaces. So getting spacers behind the knife boxes, making sure the knife boxes are drainable and that sufficient enough that you can get all the product out of them. I've seen some of them with very small drains on them, and you start to get larger pieces of product and difficult to get everything out of the bottom. So bearings and lubrication, you're out doing a hygienic design. We've got a lot of bearings that are adjacent or right next to food surfaces as they are in the facilities as well. We've got the difficulty that we don't have low pressure water for most of the sanitation in the field. So you've got 3000 PSI, you've got the ability to damage bearings very easily. So we need to look at, do we have the right tools? Do we have the right equipment? And if this is in on a PEC and we see this kind of buildup, what are we missing on the routine clean as far as chemical or brushes or tools to help prevent having this buildup occur on the bearings and the housing? So, and then in the picture to the right, there's a, this is a tough design. You've got a sandwich joint of two stainless pieces coming together. You've got some, what looks like maybe over greasing or some issues with pressure washers knocking grease off. So again, it's a review and understanding what can be done to protect these bearings, clean them properly, and not have that kind of buildup and sticky harborage point to capture food particles and moisture. Auxiliary tarps is another one. So we start to look at, we get the harvesters and we go through there, but on design and SSOPs and just familiarity of when things get done and how they get done, it's another thing to look at while you're out looking at tractors and things that might be attached to your 3-point harvesters. And so just kind of wrapping up, you go out, you do your hygienic design review, you've marked some things that are problematic and a challenge, and you don't stop harvest, you're progressing and getting better. But then you should take a look at your SSOPs and look at the tools. And one thing that we see a lot of is kind of the underestimating the size and the volume of the detergent desired amounts that need to be applied to surfaces. So we see like a 2 or 3 gallon pump sprayer. And I've got an example we'll show after this, but this picture here is, imagine a shot glass and then a drinking glass. And if you were to apply that to a square footage on a harvester, are we really getting contact time? Are we getting good wetting of the surface if we're applying it to running belt? Are we seeing that detergent spray off? So if you're pouring a shot glass on every square foot of food contact surface versus getting 12 ounces on the surface so that you can scrub and go, these are the things we need to account for. If we're going to use smaller pump sprayers, maybe we need to have duplicate or triplicate to make sure we've got good wetting and detergent application. And we've got a lot of things we've done with pressure washers to have venturis to draw in chemistry so that you get ample application. And so if you're looking at a poor design or a challenge design, we really want to look at your SSOP and what you're doing and capable of completing. So this is just some of the math on it. Again, I think this is being recorded and I'm happy to share this, as needed. But if you have 80 feet of that lateral horizontal conveyance, and then you've got an incline, and let's say the belts are 18 inches wide, you're talking about 240 square feet of direct food contact surface on the top and underside of the conveyor. So then you look at side panels, you might have 360, you get out guides, bin feeder, all that. Okay, we got 700 square feet. You go through there, and that's how I came up with the half ounce. So if you had 700 square feet of food contact surface and you're using sanitizer and detergent on everything else, do we really have enough to get the job done? So coverage versus contact time, scope of use. So we're using it on the non-food contact. And if we're working with that design challenge, we need to make sure we got the right tools, right chemistry, time, and staffing to get it done. So that's kind of the quick what to expect when you're out inspecting equipment, and open it up to questions.
Thanks, Justin. We do have 2 questions that came in. First one from Jack. He says, some equipment is fairly common, like Ramsey Highlander, self-propelled belt, Dragon. With that in mind, would it be feasible for LGMA to facilitate the creation of a cleaning manual for some of the more common equipment? I guess that's for Greg.
That's a great question. We haven't, as the LGMA, really gotten into the space of creating those specific specs for equipment. As part of our Smarter Audit program, we did look at a phase 3 approach where we look at very commonly used things to see if we can't help the industry with creation of either reducing kind of document loads or creating a standard that helps with the reduction of document loads. But haven't looked at the specific development of specific like cleaning manuals or, even a kind of a process for validating a product that you apply to your soil or something like that. We're looking at stuff like that, but that's going to be years away in development. I do know some of those companies are obviously very keen on what's going on with the industry and may already have some of those kind of being developed. But Justin, that's where I'm going to punt to you. Do you know of some of those equipment designers that are maybe starting to develop some of those manuals as well?
Yeah, I don't know that the equipment guys, they've been available for sure on design discussions and whatnot. But as far as a sanitation manual, we've worked with a lot of companies. As much as they're all very similar, they depends on the year they were built and what products you're running. So you start to see some variances in belting, so um, it's a fairly quick fix to go through. And I think that the Appendix S has some, just good basic guidelines for what needs to occur. And then you do your hygienic review and then call out specific needs on the nuance to, but if you've got 6 of the same machine, you should be dealing with pretty much the same SSOP and maybe some different belting or conveyance on some of them.
We did have one other question from Luis. Does your assessment or review or your risk assessment change based on water use during harvest? So would you classify risk higher on a mower that uses water during harvest versus a mower that harvests dry without hydration or rinsing?
Yeah, water activity is always a big piece. So anytime you're introducing water, it becomes a challenge. So you want to make sure you've got that managed from chlorinated water source. And then you want to look at where does that water accumulate and what, are the belts and rollers and everything designed to shed that water? Or are we really looking at a lot of buildup? So definitely would put a higher risk onto the wet harvest versus the dry. Just from a standpoint that you've got 6, 8, 12 hours of harvest with high moisture and ground up product versus lower moisture. Still got ground up product though. So
I've got a quick question for you, Justin. Maybe not a quick answer though. So one of the things that we've heard from the membership is just kind of your point about, you're doing the hygienic design review. There's a range of 0 means there's no problem, up to 5 is don't use this equipment, it's dangerous type of thing, right? So as you're going through your assessment, right, and you find a challenge spot, right? Say you give it a 3 or a 4 or something like that, and you start using data like ATP to show kind of that how I'm able to clean it or whatnot. At what kind of level are you seeing folks like if you start say I have a 2500 ATP after before cleaning, and when I'm done I'm still really high because the cleaning is really difficult. What number would you have to see that shows I've improved the design? You know what I'm saying? So would you have to go from 2500 to 250, like a log reduction? You see what I'm saying? Like, what are you kind of telling people from a data perspective on how that informs? I'm feeling more comfortable about this equipment being not as dangerous. Does that make sense?
Yeah. So I think there's kind of 2 pieces: the design and then the sanitation process. We do a lot of our training and support with collecting what's dirty. So the first thing to achieve clean and what we can do is what are the numbers that we're seeing on those surfaces prior to any cleaning, rinsing, or anything. And then the second one is to do it after just a rinse. So a lot of us have a chlorinated water source and a pressure washer, and looking at incrementally what are we achieving or how are we getting those numbers down. So a good example would be like on a charm ATP meter, we might see 1.5 million on a dirty machine. High soil load, organic loads high. You go in and do just a pressure wash with chlorinated water, and you see that number maybe cut in half. So now you're looking at maybe 700,000 RLUs. So then you take your tools, your detergent, put your best effort into it, and then see where you're falling in. And our goal on the charm meters is to be less than 20,000 based on a lot of different things, but aerobic plate count, coliforms, numbers that we've seen, you start to get that threshold to say, can I get below there? And it's not just using ATP, and there's no direct correlation between ATP and APC, but the quick response in the field is to get that ATP down. So 1.5 million, get down to 700,000, and then see a detergent and soap step that are getting you down into that close range, and then take samples. post detergent and then look at your sanitizer application. So if you get post detergent, how well are you cleaning and removing all the soil load and micro load? And then how effective is your sanitizer? So again, that's that last slide. If you're putting 2 gallons of sanitizer on 700 square feet of surface, are you really getting good contact time? Are you really getting good wetting of the surface? And then go ahead and get a sample post sanitize. So now you've got a snapshot of what your soil load is and how you get it down. And if you get to a spot where you're just not able to knock those numbers down, then you start to really look at like, what is my belt accessibility? What are the right tools, angles, areas that are dripping and drawing onto other, one conveyor is hitting the next. So it's really a process, but it's a quick process. It's 1 or 2 days out in the field to see what you can do to get those numbers down. And once you establish that, you can look at your PEC. So when it's in the lot or in the yard for tear down, is get those numbers down to 0 if you can. See how clean you can really get it, and then watch as you go through with your routine cleaning. So.
We have no other questions in the chat. I do have one additional question, Justin, and it was the earlier slide you had where you're talking about the trial equipment, prototype equipment. So I know that was one of the things that we talked about was what would you recommend folks do as far as their own company policies regarding the use of this equipment and shipping product and things like that?
Yeah, it's difficult because there's a lot of great ideas and companies coming up with, trial pilot pieces of equipment. And in order to prove the technology, they need to run pounds on it. And depending on what the what the box prices are and how things are going. So I think before anybody allows for trial equipment to run in the field, they need to do the hygienic design review, and they need to realize that if the production needs are met, what would the true cost of that equipment be if it's designed to really be cleaned and maintained? So that's step one. And then step two is to look at pilot runs where the product's first discarded, and then look at the ability to return that machine back to clean, so that you could say, okay, we may allow product to be packed on this equipment, but you really got to take a pragmatic approach to say, okay, what are we dealing with? What's the real cost? That's the other part that I think I've seen some companies get burned or close to burned on is, okay, the intent of the equipment is to get something done, but the idea or the manufacturer hasn't really taken it to full food safety review and design. So they don't have an idea or really the means to get the 316 stainless and the non-padded rollers and various things. So having a meaningful discussion to what this equipment will really cost to meet your needs in the field.
Well, I know we ran a little bit over than what we wanted to. With that, I think we'll end today's lunch and learn. Keep a watch out for future ones. I know Justin and I are in the works with maybe doing a few more of these throughout the remainder of our year. So keep an eye out for that. And with that, I just want to thank you, Justin, for doing this afternoon. And again, keep an eye out for the recording. And if you have any other questions, please send them our way. You can send it to me, Greg, at lgma.ca.gov, an email, and we'll try to get you any answers that we can provide. And with that, have a great day. Thank you for attending.
Thanks.